projects. In this video, we are going to explain about the project, which is Ensemble Hybrid Learning Methods for Automated Depression Detection. Introduction of the project. The drastic changes in contemporary lifestyles have contributed to a surge in depression cases, earning it the name of a disease of modernity. Projections indicate that by 2030, depression may become one of the top 3 causes of illness, emphasizing the urgent need for effective detection and intervention. The social stigma surrounding depression and high misdiagnosis rates hinder access to proper care, serious mental disorders, if left untreated, that may escalate to suicidal ideation. Overcoming these challenges requires timely detection of depression, emphasizing the importance of effective screening methods. Cognitive and linguistic studies reveal that individuals with depression exhibit distinct language patterns, analyzing language features such as increased use of first-person singular pronouns and negatively valenced words, providing insights into potential depressive symptoms. Online social content, particularly from Reddit, Twitter, offers a rich source for automatic mental disorder detection. The anonymity and accessibility of social media make it a valuable tool for studying individuals' opinions and emotions, especially when traditional sources are less accessible due to stigma. The project proposes a hybrid system merging AI with deep learning and explores ensemble methods to enhance accuracy in automated depression detection from social media text. The approach integrates sentiment lexicons, logistic regression, and experiments to contribute advancements in text classification for depression detection. Objective of the project. The objective is to detect potential indicators of depression by examining language patterns, emphasizing the analysis of first-person pronouns and negatively valenced words to identify and understand symptoms in individuals. The aim is to investigate a range of natural language processing methods, including lexicon-based comparisons and machine learning algorithms, to comprehensively explore the effectiveness of diverse techniques in identifying language markers associated with depression. The objective is to assess the effectiveness of different classification methods, including precision, recall, FS score, and accuracy as performance metrics. This evaluation will provide insights into the strengths and weaknesses of various models and features, enhancing the accuracy of depression detection. The goal is to explore the synergies between different NLP methods, seeking the optimal combination of models and features that collectively enhance the accuracy of depression detection. This investigation will contribute to understanding how the integration of diverse approaches can improve overall performance. The objective is to critically analyze and discuss the outcomes of the objective, including the achieved performance metrics. Through this discussion, the aim is to gain valuable insights into the effectiveness of applied NLP methods for depression detection and their potential implications for future research and implications. To implement this project, we need software and hardware requirements. Coming to hardware requirements, we need operating system of Windows, processor of i5 and above, RAM of 8GB and above, and hard disk of 25GB and above. Coming to software requirements, we need application of Anaconda, primary language of Python, front-end framework of Flask, back-end framework of Jupyter Notebook, database of SQLite 3, front-end technologies of HTML, CSS, JavaScript, and Bootstrap 4. To execute this project, we have designed various steps in the flow of work. So the first step is importing the packages. In this step, crucial Python libraries including Pandas for data manipulation, NumPy for numerical operation, Seaborn and Matplotlib for visualization, sklearn for machine learning, TensorFlow for deep learning, and NLTK for natural language processing are imported. This module establishes the foundational environment for subsequent data manipulation, numerical operations, and data visualization steps. The next module is exploring the dataset. In this module, the dataset is loaded and explored, allowing for comprehensive understanding of its structure, contents, and key characteristics. Visualization. Moving forward, data visualization techniques are applied in this step, providing a graphical representation of the dataset's insights through charts, graphs, or other visualizations. Matplotlib and Seaborn are employed in this step to create visualizations such as histograms, scatter plots, and word clouds. This module aids in identifying patterns, trends, and potential outliers in the data. Coming to the next step, which is data processing. In this stage, various data processing techniques are implemented to clean and prepare the dataset for analysis. Here we have multiple techniques Coming to removing the URL and other characteristics, this step involves using regular expressions or string manipulation to eliminate URLs and unwanted characters from the text data. Here, punctuation marks are stripped from text using string manipulation techniques. Common words like and, the, and, is are removed from the text. Text data is standardized and normalized, ensuring uniformity in the representation, which can solve stemming and lemmatization. Coming to tokenization, in this we have two substeps which are count vectorizer. Coming to count vectorizer, it is employed for converting a collection of text documents into numerical format that machine learning models can understand. It builds a vocabulary of unique words present in the entire dataset for each document. It counts the occurrences of each word in the vocabulary and create a matrix where rows represent documents and columns represent unique words. The result is a sparse matrix with each entry representing the count of specific word in a particular document. Commonly used in traditional machine learning tasks like text classification, sentiment analysis, and document clustering. Coming to the next method, which is Keras tokenizer. This module applies the Keras tokenizer to tokenize the text data, converting it into a sequences of integers for further processing. Keras tokenizer is designed for pre-processing text data specifically for neural network models, especially those built using Keras deep learning library. It builds a vocabulary of unique words in the dataset and assigns a unique integer index to each word. Each document is then represented as a sequence of integers based on these indices. The output is a sequence of integers for each document where each integer corresponds to a unique word in the vocabulary. Primarily used deep learning applications such as training recurrent neural networks and long short-term memory networks on the text data. Coming to building the model, in this step the architecture of the machine learning and deep learning models are defined, outlining its structure and components. The next module is training the model. The model is trained using labeled dataset where the input, which are features, and output, which are labels, are fed to the model iteratively. This training module involves adjusting the model's weights to minimize the difference between predicted and actual outputs. The next step is Flask framework with SQLite for sign-up and sign-in. This module, Flask, a Python web framework, is implemented. SQLite is a lightweight database is integrated for user authentication, enabling users to sign up and sign in securely. The next step is user gives input. To a web interface, users provide input related to mental health. This input module includes text describing their feelings, experiences, and thoughts. The next step is given input is pre-processed for prediction. The user inputs undergoes pre-processing steps similar to the initial data processing. This module ensures the input is in format compatible with model's expectations. The next step is training the model for prediction. The pre-processed input is fed into the trained model, and this module predicts outcomes related to mental health, such as likelihood of certain conditions or sentiments. The next step is LDA model for topic modeling. The latent Dirichlet allocation, which is LDA model, is applied in this step to identify underlying topics or themes within the user's input. This provides additional insights into the content. The last module, which is final outcome, is displayed through frontend. The results of the predictions, topic modeling, are displayed on the user interface. This front-end output module provides users with insights into the analysis of their mental health related input. Algorithms which are used in this project are LSTM, which is long short-term memory. It is a type of recurrent neural network architecture designed to address the vanishing gradient problem in traditional RNNs. LSTM are equipped with memory cells and a system of gates that control the flow of information, allowing them to capture and learn long-term dependencies in sequential data. The architecture includes input, forget, and output gates, enabling the model to selectively remember or forget information over extended sequences. LSTMs are well suited for tasks involving sequential data, such as natural language processing. In this project, where the goal is to detect depression based on language patterns, LSTMs can effectively capture the intricate dependencies present in textual data over extended context. The next algorithm is LSTM with attention. It augments the standard LSTM architecture by incorporating an attention mechanism. Attention mechanism allows the model to focus on specific parts of the input sequence when making predictions. This enhanced capability enables the model to pay varying degrees of attention to different parts of the input, providing a more nuanced understanding of the data. Attention mechanisms are particularly valuable in tasks where certain elements in a sequence carry more importance. In the context of depression detection, attention can help identify critical words or phrases that may indicate mental health concerns and allowing for more precise and context-aware predictions. The next algorithm is logistic regression. It is a linear model used for binary classification tasks. It models the probability that an instance belongs to a particular class using the logistic function. Despite its simplicity, logistic regression is widely used for interpretability and efficiency. It serves as a baseline model for binary classification, providing a straightforward and interpretable approach. It allows for an initial understanding of the classification problem, and it can serve as a benchmark for evaluating the performance of more complex models. The next algorithm is LSTM with LR, which is logistic regression. LSTM with logistic regression is a hybrid model that combines the strengths of LSTM for sequence learning with simplicity and interpretability of logistic regression. The LSTM extracts features from sequential data, and these features are then used as input for a logistic regression model for the final classification. This hybrid approach aims to leverage the sequence of learning capabilities of LSTM while benefiting from the interpretability of logistic regression by combining these two models. The architecture seeks to achieve a balance between complexity and transparency, making the model more interpretable while maintaining the high predictive performance. As an extension, a hybrid method is used for improving the accuracy of the project. And also we built front-end using Flask framework for user testing and user authentication. We have evaluated this project using different classification metrics, which are accuracy, precision, recall, and F1 score. So here we have accuracy comparison graph, where on x-axis represents accuracy score for each algorithm, and on y-axis we have algorithm names. Accuracy is a measure of overall correctness of the model. It calculates the ratio of correctly predicted instances, which are both true positives and true negatives, to the total number of instances in the dataset. In the context of depression detection, accuracy reflects the percentage of correctly identified cases of the depression out of total cases in the dataset. A higher accuracy indicates that the model is effectively distinguishing between individuals with and without depression based on their language patterns. Here we have precision score comparison graph, where precision measures the accuracy of positive predictions made by the model. It calculates the ratio of true positives to the total number of positive predictions. In depression detection, precision assesses how accurately the model identifies individuals as having depression among those it predicted as positive. A high precision indicates that when the model predicts depression, it is often correct, minimizing false positives and the likelihood of mislabeling non-depressed individuals. This is the recall score comparison graph. Recall is also known as sensitivity or true positive rate. It measures the ability of the model to capture all positive instances. It calculates the ratio of true positives to the total number of actual positive instances. In the context of depression detection, recall assesses how well the model captures all individuals with depression among the total number of actual depressed individuals. A high recall indicates that the model is effective at identifying individuals with depression, minimizing false negatives and the risk of overlooking cases. Coming to F-score, which is F1 score, it is the harmonic mean of precision and recall. It provides a balanced measure between false positives and false negatives. F1 score in the depression detection serves as a combined metric considering both precision and recall. It is useful when there is a need for balance between minimizing false positives and false negatives. A higher F1 score indicates a model that achieves good compromise between precision and recall. To execute the project, first we need to open the code folder which contains source code files. So this is the code folder of the project. In this folder we have the dataset on which we will be training the algorithms. And this is the static folder. This folder consists of files related to CSS, JavaScript and Bootstrap files. This is the templates folder. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. Here we have app.py file. This .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content that to be rendered in HTML templates. This is the notebook.ipynb file. This is the Jupyter notebook file which contain a combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for the data science. This is the signup file, which is the database file used to store the user information. And here we have the model file which contain the algorithm information and that will be loaded into the project code during runtime. To execute the project, first we need to copy the path of the code folder from the address bar of the file explorer. So I'm copying the path. Now we need to open the Anaconda prompt. Using the cd command followed by the space, we need to paste the copied path and click on enter. This will change parent directory to the code folder's path. Here we need to type command which is python space app.py and click on enter. This will compile app.py file and this command will execute the Python script and perform a runtime check for any syntax errors or logical issues. After running app.py file, the Flash framework will host the application locally at the default address, which is the localhost and the port. This is the localhost and this is the port. And let's configure differently. Now we need to copy this local link provided by the framework and paste it in any web browser. I've copied it. I prefer Google Chrome, so I'll paste it in that. Here we need to paste the link and click on enter. Here we can see that web page of the project is displayed in the browser and this web page is built by using the Flash framework. Here we can see a sign up link. First we need to click on it and enter all the sign up details if we are signing up newly. I have already signed up and I have an account in it, so we'll directly click on sign up. Here we need to provide our credentials, which are the username and the password. So I'm giving my username and the password. And now we need to click on login. I have entered wrong credentials, so we will enter them again. We have logged in successfully and we are redirected to page where we need to do the prediction. Here we can see a text box where we need to give the input message here. Based on the given message, the system will predict whether the person is depressed or not. Here in the notepad, we have some of the test cases where we will use them for prediction. So I'm copying the first text and we'll paste it here. And now we will click on predict. So here we got the prediction. The user has no potential sign of anxiety or depression, which means the person is not depressed. And here we have the topic for paragraphs is the most dependent upon these words. Now we will give the other input and see what will be predicted. So click on home. Here we will enter the message. From the notepad, I am copying the sixth message. And now we will paste it here and click on predict. So here we got the prediction. The user shows potential sign of anxiety or depression, which means the person is depressed. Here we have topic for paragraph is most dependent upon these words. In this way, if we give the messages to the system will predict whether the person is depressed or not. Now we will sign out. Conclusion of the project. The project successfully explored and integrated various natural language processing methods, including lexicon-based comparisons and machine learning algorithms, demonstrating their collectively efficiency in identifying language patterns associated with depression. Through the systematic experimentation, an optimal combination of NLP models and features was identified, showcasing the significance of leveraging diverse approaches to enhance the accuracy of depression detection. The evaluation of various classification methods employing metrics such as precision, recall, F-score, and accuracy provided a comprehensive understanding of the strengths and weakness of each model, contributing valuable insights for future research and applications. The analysis of language use, particularly the emphasis on first-person pronouns and negatively valenced words, yielded significant insights into potential indicators of dispersion, offering a nuanced understanding of linguistic cues in mental health detection. The project's outcomes contribute to the evolving field of automated depression detection, providing a foundation for future research and emphasizing the importance of combining diverse NLP methods for more accurate and comprehensive assessment of mental health through language analysis.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.